So yeah, as I mentioned, the model is inspired on the Norne Field, and we have taken the liberty to edit the NTNU model to account for certain uncertainties in the field. Some uncertainties are structural uncertainties, and some other are stratigraphical uncertainties. But the model that we are going to run primarily, and I'm going to try to show you very briefly how the model looks like. This is the simulation model. It has actually quite a few wells. As you have seen in the image, it's basically a subsea tieback to an FPSO with quite a few manifolds, a couple of injection manifolds, 4 production manifolds, and there is an additional manifold for the production of this sort of terrace or elevated area of the field. What we have done, it's as I mentioned before, we show you some of the structural, some of the uncertainties that we have taken into account. You can see some of the wells, and most of the producers, or all of them, are horizontals, and there are some water and gas injectors. What we have also, and let me go back to the presentation. So what we have done, it's taken a couple, well, 1, 2, 3, 4 development scenarios for the field. So the first one, it's where we pretty much develop only with drilling, just the initial drilling of a well without any intervention due to water shutoffs or any other activity that might be needed to add additional resources to the production forecast. Then we have a drilling and workover where we add more wells. Actually, these wells, the wells that you don't see here, like the B4, BH, it's actually in the initial case, but we have an intervention that is a switch of a zone, mainly due to water cut and water eruption. And then we also have a case that we have put together, which is a drilling plus a workover, and then a WAC. And the final case, we have these three options, plus we have a terrace where we are developing this area with one producer at the top, because as you have seen the image is it's quite tilted, this terrace. So this is pretty much a summary. What you see in blue are the injectors, and as you can see, there are quite a few of those. And what you see in red are the gas, the wells that were switched to gas injection in the WAC scenario. So these wells at the bottom are the workover wells. So when we provide the scenarios in the GitHub, you'll have this Excel as well, so you can have a look and see what's happening as well. So if I show you more or less the scenarios, how they look like, let me load them. So we have these 4 scenarios: the base case, the workover plus WAC, and we also have the scenario with the terrace. So more or less, just for you, in order you to see the incremental production and what it means in terms of production. This is a base case. Then we have a base case plus workovers, base case plus workovers plus WAC. And as you can see here in the WAC, there is a bit of the acceleration of the production when we switch to WAC, but ultimately it brings more production. So at the end, I don't know if we will have the time, but these are the kind of things that are very interesting to see in the economics, whether it's worth going for WAC or not. And the terrace, it's the ultimate production of a terrace, as you can see in this couple of wells. It's is the added production on this final scenario here at the top. Okay, so having explained that, so the common approach, and I think it's what Esther is illustrating. It's we have all the models that ultimately a reservoir engineer have to cast into an Excel, and that Excel usually it's it fits another Excel, which is an economic model, that the one that Excel the one that Esther is showing. Usually the price is embedded into the economic model, and some corporate and fiscal assumptions are also incorporated into the economic model. Cost as production are brought into that Excel, and then you have some KPIs that can be visualized and analyzed, as Esther mentioned. And what we would like to show here, it's let's talk about some of the pains of this particular approach. So what about if we have quite few scenarios? So every one of these boxes that you see here is an actual subsurface models, because in reality, what the reservoir, what the reservoir engineer is doing is having quite few scenarios like the one that I'm going to show you in a bit. So the reservoir engineer may have, actually, let's load a scenario to illustrate the point. For what is the base case or the reference case, where we have only drilling and no workover, there might be quite few more scenarios. And it might be just a bit of a range like this one. So this is what the reservoir engineer is actually producing. But obviously the economist is it's only going to consume few of those scenarios. Ideally, we'd like to see how every one of those scenarios would perform. And ideally, we would like to see different cost scenarios, because as we mentioned, we know that this platform was developed with an FPSO, but there are a few questions that we can ask. If we displace all these scenarios into the future and we try to make a decision of how to develop the field, then we are talking about assessing the possibility of renting an FPSO, leasing an FPSO, purchasing an FPSO, or probably developing with a platform if the resources are actually enough to accommodate a higher level of production demand, or probably a subsea tieback to a nearby facility. So there are a few cost scenarios, and actually there are many cost scenarios, because there might be even the possibility to associate different timings to the wells, or different drilling strategies, and so on. So these are the 4 scenarios, and as you can see, we have 4 subsurface models. We have the economic model itself, which contains different price tags. As Esther mentioned, this is a very critical part of a workflow, where you need to evaluate the pricing estimated by different agencies. You probably have consultancy firms that are providing their own estimates of the futures, the prices of the future price of oil and gas, or you have your own estimates that you would like to run based on your corporate assumptions. Plus, you have all the fiscal regimes assumptions, plus other internal corporate assumptions. So there are quite a few scenarios that you want to work. And as you can see, these are quite complicated. If you start to permutate all the options, it's quite a large number of scenarios. So what are the challenges here? Well, the traditional data storage processing of these workflows is in Excel. It's what I showed before. So which leads to a massive multiplication of and a split of files, because what's happening, we usually work in Excel, and these files cannot contain the amount of information that we need to handle in order to progress with the evaluations. So we have to split all the different studies, and it's very complex to run the scenarios as the problem evolves. But because let's be honest, these scenarios that we have here, the reservoir engineer, it's evolving into the analysis. The cost estimates are also evolving, and the price deck is also moving forward. Fiscal regimes may be evolving as well. So this also makes the whole economic evaluation quite complex as the time moves forward. The stakeholders, as we mentioned here, they work in multiple formats. They work in whatever format they want to supply the data on. And usually it's down to the economist that it has to aggregate all this information from different multiple sources into a particular format. So this leads to an excess of manual intervention, slowing down the decision-making process. And also the less amount of iterations that we do, the less knowledge that we can gather to inform the decision that we are making. And as we are using Excel, there is a limited economic engine performance, especially when we start to leverage into the use of multiple economic sensitivities, if we're going to do sensitivity analysis, uncertainty analysis, and so on. So what we're going to talk here, it's what we have, sorry, shouldn't be these arrows here. Well, let's talk about the possibility of having now a web server. And in the web server, we can bring some of the simulation results. So now all the production forecast is on a web server. So what is the advantage of this? Well, everything is sitting on a database, and everything is sitting on a web server that can be accessed through authentication, okay? And the other thing, it's all the Excels can actually fit the database. And ultimately, what we want to run is take our economic model for this particular exercise. We're going to run an economic model by pulling the data from the web servers through APIs. And additionally, if we have scenarios that are evolving, we can have the data from these prices agencies. Also, we can connect through their APIs and pull the data into our databases and continuously evolve in the economic evaluation process.